All right, can everybody hear me? Good Lord, I'll be blind by the time this is over. Well, welcome everybody. Hopefully everybody's awake now. You got enough coffee. I probably had a little too much coffee, so a little antsy. My name is Paul Luse. I'll let these guys introduce themselves as they go through their portions of the talk. What we're going to talk about today is not so much what is software quality, but what does software quality mean to the SPDK community, and how do we see things funneling up into software quality. I imagine just about everybody in here has read books and gone to classes and gone to seminars and talked with other people about software quality and has a million different ideas on what metrics to track and how to look at your code complexity and how do you look at your the number of bugs and your closure rate and all that kind of stuff. That's not what we're going to talk about. That's way too boring. We're going to talk about fun stuff. And we'll cover pretty much everything that's up here. So let's jump right into it. Software quality and SPDK. So I've got a lot of stuff on here that's probably non-traditional from what you've seen when you hear about software quality, other than maybe the first one, right? Software testing. I have to include that one, right? Software testing is what most people think of when they consider software quality. That's how you keep your quality up, is you keep testing things, right? You keep finding things, you keep fixing things, and that increases your quality. But there's a lot more to it than that. In an open source community, teamwork is huge. It's so much more important than working in a tight group of people, right? When you work as a tight group of people in a proprietary environment and everybody knows each other and everybody is, depending on who you work for, competing with each other, and everybody's trying to do the right thing for the project, and you're kind of forced to work as a team. But in an open source community, you have to do a lot more to pull a team together when you're worldwide and when you've got companies from all over the place. Right? It makes it a lot more difficult. So we have a conscious effort to pull people into the community, to interact with people, to encourage people to ask questions and to present their ideas. That builds the teamwork. How is teamwork associated with software quality? Well, we want the best we can get. We want groupthink. We don't want one person saying, I know what to do, I'm going to do this. Right? The best quality comes from a bunch of different eyes looking at it. All right, process and automation. Another really, really key aspect to software quality in an open source project, probably the same in a closed source project. I've been in open source for so long now, I don't even want to think about the closed source days. But process and automation is really what enables us to focus on the code, right, and focus on the community and to focus on building the best thing that we can build as a community. So you'll see when Seth and Darek go through their slides, you'll see what our infrastructure looks like, all of the things that happen behind the scenes when you hit submit, and all the tools that are responsible for that. So process and automation allow developers to focus on developing. All right, software design. It's probably fairly obvious that software design is a key part of quality and that you want to make sure that your original design makes sense, so you don't end up wasting time or doing something that has a bunch of gaps in it or features in it that make no sense. Now, anybody that's spent a lot of time looking around the SPDK documentation knows that we don't have a lot of design docs. That doesn't mean we don't have high software quality. It just means we would rather developers interact with each other real time to work out the issues, to ask their questions, to come up with a design, than sit in a back room somewhere and write a bunch of UML and spit it up there and say, here's what I'm going to do. That doesn't mean we don't have any design documentation, though. We do have a lot of good examples of design docs, and we encourage people to write design docs when, A, they need them to work through the design in their own heads. Might as well capture it and share it with everybody else. A lot of people like to write design documentation because it helps them organize their thoughts and helps them identify pitfalls along the way. And the other time that we think it's really important is when it's fairly complex, right? It's just too complex to get on IRC and say, hey, I've got a great idea. I'm going to blah, 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 blah. Well, show me a picture, right? Show me something, because I have no idea what you're talking about, right? So it goes back to teamwork. You can't work as a team unless you are generating documentation as needed. All right, having fun. So we'd like to have fun in the SPDK community. We'll have a lot of fun tonight when they open up the bar. Fun is really important. I actually can cite a couple of different research articles. There's research available on absolutely anything that you could possibly imagine. But there are research articles about happiness and software developer productivity. Right? Software developers that are happy, that are having fun, that are doing that are having a good time, tend to develop higher quality code than software developers that are not. Right? And it's not. I don't think it's that difficult to understand why. Right? Happy developer is a good developer. Right? So we like to have fun. You'll see us joke around a lot on IRC in the mailing list, and that is on purpose. It's because we want people to have fun. Okay, documentation. So this is a little different than design docs, right? This is the documentation about how you use SPDK, what SPDK does, how you configure it, right? It's sort of like the user's guide. And it's always a work in progress, but it's really important for software quality because as a new developer comes into the community and decides they want to start adding a feature, they have to understand what's there already, right? And if it's not clear what's there already, it's easy to put something in the wrong way or in a manner that doesn't support the existing architecture, right? Those are bad for software quality. So we continually try to keep a focus on this documentation, not just for the end users, but for the developers to understand everything they can about SPDK before they write their first line of code. All right, and last but not least, kind of goes with the teamwork and the fun, is communications, right? So if you're active in the community, you know that we have weekly meetings at different time zones. So we have a Wednesday night meeting, US time, at 9 p.m. where we cover the Asia Pacific region. And then on alternating weeks, we have a 7 a.m. meeting, or 9 a.m. meeting, I can't remember what it is, to cover the European time frame. Okay, so we've got maintainers, core maintainers, in the US, in Poland, and in China. So pretty much 24/7, you can get a hold of somebody. Our community meetings are meant to be wide open. Right? Anybody can call in, anybody can ask anything they want. We do ask people to post their agenda topics in advance if they can. It just helps everybody get prepared for what the meeting is going to be about. But it's not required. You can come into the meeting and just say, hey, I have a question, or I want to discuss this or that or whatever. And that happens quite a bit. And these are very productive meetings. We get a good number of people call into these all the time. Our other big communications channels are IRC. That's probably the best way to get a real-time answer. Like I said, we've got people around the globe that are on IRC all the time, just part of our work habits. So we're there for questions, for collaboration, for anything. And then there's the email distribution list for those that don't like IRC and would rather have a big, long email chain in their inbox. I'm not one of those people. But we've got it if you want to use it. Okay, so all these things together is how we keep the software quality of SPDK high. All right, now I'm going to turn over to Seth, who's going to talk a little bit more about the testing aspect.
Great. Thank you so much, Paul. I'm going to take the clicker from here. Thank you. Great. Well, like Paul said at the beginning, all of you have been developing for years, sometimes decades. You know what testing is in software. You know the different types of it. I'm going to go through the types of testing that we have in SPDK, not to really rehash how you write a unit test or how you write a system-level test, but to talk about some tools that we have in SPDK to make that easier, and also to give you an idea of where each one of you as members of the community can start contributing to the testing and the software quality of SPDK. So of course, the first type of unit test that we have in the SPDK repository, or the first type of test that we have in the SPDK repository are the unit tests. These are foundational. They're best created right when you first submit a patch that contains new code. And the importance of that, of course, is to lock in the logic of that function at the time that it's created. Nobody knows better what you intended to do with a piece of code than you, the person who wrote it. So by locking in the unit test at the exact same time that you write the function, you can prevent somebody else from coming along later and unknowingly messing up the output or the side effects of your function. In SPDK, we use the CUnit framework for all the unit tests. They're checked into the SPDK repository under test unit. and they're done per API file. Okay. So the next one is the system level testing. And for every patch that's submitted to SPDK, we run a whole suite of system level tests before that patch can be merged. These system level tests really test end-to-end functionality. For example, we've got several different tests for the Nvme over Fabrics target that do things like building a file system on top of a block device exposed by the Nvme over Fabrics target, or repeatedly connecting and disconnecting from a target. These, of course, are useful for specific use cases. So as a community member or developer, if you see a use case that you have that isn't being regularly tested in the system level test, you can take you can take a look at the example applications, as well as all of the bash scripts that we have to orchestrate those example applications, and see how you can add an additional system level test to get coverage where you're not seeing it currently. And in regards to these two types of tests, as I said up here, they're run on every single patch that's submitted to SPDK. But as a developer, as you're submitting patches to the SPDK review process, the simplest way to make sure that your patches are reviewed very quickly and merged very quickly is including unit tests and system level testing in the same patch where you add new code. And luckily, we've got Darek Stojaczyk here. He's one of the SPDK core maintainers. And I'd just like to turn time over to him for just 1 second. Darek, what is the difference for you as somebody reviewing code that's about to go into SPDK when you look at a patch that does have system level tests and unit tests as opposed to one that doesn't?
Okay, so when I review a patch and I see unit tests there, I usually start by looking at those, and I see how the code works as a black box. It gives me the confidence that your code actually works, and that's huge.
Great.
And if they don't have unit tests?
Oh, if they don't, they go to the list.
Yeah. All right, thanks so much, Darek. And if you are interested in getting started with writing tests in SPDK, we have a really great coverage tool that we use on every single patch that's run through our continuous integration framework that will actually show you exactly which lines of codes are and are not covered by the unit and system level tests. So by going in and looking at a line that's highlighted in red there, it gives you an idea of where you could start if you wanted to contribute unit or system level tests. Right.
So Seth, that sounds like a great way for somebody who wants to get involved with the community to go do something that is fairly low risk and high value add, right? They just need to go look at the coverage reports and find something that says 40% and see if you can bump it up to 80 or 90%.
Yeah, if you want to get on Jim Harris's list of most favorite people in the world, just write some unit tests.
Yeah, so you don't have to write a patch that has code and unit tests. You can just write a patch to beef up existing unit tests.
Yeah, oh, exactly. I can't guarantee this, but you'd probably end up like, on his holiday card list or something. He loves it. And for good reason. These kind of tests really guarantee the day-to-day functionality of the code and keep the software quality high. Another really integral type of testing here is performance testing. I think all of us are here because we know that SPDK is a very highly performant piece of software. And the goal is to always keep it that way. We've had manual performance tests run plenty of times throughout the past. Something that we're working on as a community right now is actually automating this performance test. We have an engineer in Poland, Karl Leteski, who's been doing a lot of this. And the goal of that is to be able to run a full suite of performance tests against the Nvme over Fabrics target, for example, and catch any regressions that are coming in. So we're really excited about this in the future. Lastly, and this is something that we're just getting started with, so anybody that has any experience with fuzz testing, this would be another great area to start contributing. But we're getting started with fuzz testing all of the sort of surfaces of SPDK that face untrusted areas. For example, the vhost target, the Nvme over fabrics target, and the RPCs. So like I said, again, if this is something where you have an area of expertise, it would be a great place and a huge value add for somewhere to get started. All right. So in addition, it's great that we have all these tests and all of them are checked in the SPDK repository, but none of these tests are really useful if we don't have a great way of orchestrating them through and applying them against patches before they're merged. And that's where our continuous integration and testing infrastructure comes in. I want to address two different aspects of this. The first one is the continuous integration aspect. We want to make it as easy as possible for somebody to come in and begin contributing to SPDK very quickly and with low startup overhead. And secondly, we want to make sure that a full suite of tests and a full set of reviews is done against each patch before it's merged to ensure high code quality. And I think we've struck a really great balance here with SPDK, and I'm going to go through first how each one of us can get started with contributing to SPDK, and secondly, how we ensure the high quality. So of course, when you first come upon SPDK, you see the SPDK mainline maintained at GitHub, and we have each one of us in the community with our patches, and we want to know how we get into the mainline. So at the risk of asking a question I don't yet know the answer to, how many of you have a GitHub account? Okay, good. Thank goodness. Most of us, right? And so with that in mind, we chose GitHub as our review tool. Now, GitHub is an awesome tool. It provides inline diffs for all of the code that gets uploaded to it. It allows people to comment on patches and post inline comments so that people that have uploaded code can see in real time what what comments and what revisions need to be made to their patches. It also uses OAuth with GitHub. So if you have a GitHub account, you can easily sign into the SPDK GitHub review tool and immediately get involved there. And once you've signed up with GitHub, you can post your patches there and immediately start getting reviews from other members of the community, including the SPDK core maintainers. You'll also immediately see test results coming from our CI, which I'll explain in more detail later, that will give you immediate feedback, hopefully within an hour or two, of how your patches fared against the unit and system level tests. We can then aggregate that information, and once it's passed the test and gotten enough positive reviews, it will be committed to SPDK mainline. So that's a really simple, really just a two-step process, having a GitHub account and configuring your GitHub access to be able to start contributing to SPDK. I'd like to invite each one of you to get started at spdk.io/development. There's a great user guide that Ben actually wrote for getting started. And if you have any questions or problems getting up and running, please contact me or really anybody else in the community, and we'll help you right here at the summit. So I don't want to take too much time from Darek here, but every single patch that gets uploaded to GitHub triggers an event in the Intel continuous integration hardware setup. And we use Jenkins as the backing orchestration for that. And that picks up patches that haven't been reviewed yet. It schedules, we have a whole fleet of virtual machines and physical machines to load balance that work across all of the different tests that we do. And it reviews all the patches in order and posts back the results to GitHub. We also have all the logs available online as well. Something else that we're interested in, and we've actually seen two different companies, we've seen both Broadcom and Mellanox implement this, is different companies implementing their own continuous integration off-site from Intel. There's plenty of reasons you'd want to do this, be it because you want to test different hardware or you have long-run tests that you might not be able to fit into the current system level tests. But we've had two other community members successfully implement this, and we'd love to see even more. If this is something that you're interested in, please find us after the talk, and we can talk more about how you could implement this. I'm now going to turn the time over to Darek. He's going to go through the step-by-step process of how you get an individual commit into SPDK.
All right, thank you, Seth. I'm Darek Stojaczyk. I'm an SPDK core maintainer at Intel. Yeah, and I'm going to talk about patch lifecycle. So everything starts with an idea. In SPDK, we've got huge potential to implement new features, new enhancements, and we keep track of those on the internet. Everyone can see all the ideas we have. We use Trello for that. That's, for example, where you can see, where you can find design architecture document for logical volumes. So it's a huge document describing how logical volumes were supposed to look like in their initial implementation. I don't want to scare you. Not all of the ideas for SPDK need to be described that well. There are many smaller other features that are described with just roughly a few sentences, just so that everyone knows what's going on. Well, so if you would like to see some feature implemented in SPDK, I really advise you to check out Trello. Maybe that feature is already described there. Maybe someone's already working on it. Do you hear echo, or is it just me?
No.
Okay. Okay. So after you do, when you do have a new idea, or you pick up an existing one, please bring it up to everyone's attention. Be a part of the community. So shoot us an email at the mailing list. That's the perfect place for technical discussion. You can start a discussion on IRC. That's, well, the fastest place to get some feedback, some replies. Or you can discuss your idea with everyone at the community meeting. So after everyone agrees on the overall approach on how to implement this specific feature or enhancement, because different people have different perspectives, of course, feel free to start pushing patches to GitHub. So like Seth mentioned, for every patch, our CI will run the full, SPDK integrity test suite. It will notify you whether all those tests failed or not. It will provide you with the full logs to this test suite. First of all those tests, the full SPDK integrity test suite is just a bunch of bash scripts located in the same SPDK repository as the code. So if any particular test fails on your patch, you can run that test locally, or you can also actually run the entire SPDK test suite, integrity test suite locally. So we've also got some automated test scripts, actually utility scripts, in SPDK repository to set up virtual machines capable of running this full SPDK integrity test suite. Those scripts will take care of creating emulated Nvme drives or setting up stuff like SoftRocky for NVMF testing. Yeah. And just like CI gives you +1 or -1 votes on GitHub, it's no different than, review +1 or -1s that everyone can give. But in order to get your patch merged, you will need at least 2 separate +2 votes from SPDK maintainers. Yep, go on, Paul.
So every patch goes through CI and review. Let's say I've got a patch series that's 25 of them, different submissions, and 20 of them are because I have typos in my comments. You're saying every one of those runs through CI, the entire full suite?
Yes, everyone will get run through the CI. Actually, what's more, if you push a patch to GitHub, I also advise you to add your own tests in this very same patch so that those tests can be run through the CI as well. Okay, so after the patch is merged, it's rebased on top of SPDK master. Then it's run through the same SPDK integrity test suite again, just to verify that SPDK master still works. And also, your patch will be included in all the subsequent nightly test rounds. Well, a bunch of different longer scripts that will just take care to take some more time to execute. Okay, and this is just a sneak peek at a few software quality-related enhancements that are coming to SPDK right now. Like Seth talked about fast testing. We've already been able to find a few SPDK issues with it. We've been able to fix those. I believe otherwise they would come up in a least expected moment. I'm glad we fixed those early. So yeah, I don't have much time left. So for example, with scaling the test pool, we are trying to reduce the number of resources that SPDK integrity test suite needs in order to run, so that we can, on a single bare metal machine, we can run multiple VMs running the same SPDK test suite in parallel. Okay, to sum up, all of the descriptions about, all of the information about our Trello, our SPDK mailing list, IRC, community meetings, you can find all of that on spdk.io/community. And that's it. Thank you.
15 minutes left. So if you have any questions, feel free to ask.
14 minutes.
14 minutes now.
14 minutes worth of questions.
Yeah.
Anything from anybody? Because I'll just keep talking. All right, so I'm gonna tell you something that was on Darek's last slide, and it was called security threat model. And it's a really important thing that we're doing in the community, again, to bolster software quality. It's something that we haven't had in the past, and it really what it boils down to is a process for adjudicating vulnerabilities and security issues. Okay, we only had one in the history of the project that somebody discovered in the community on an attack through vhost, but it was just one that made us realize we need to do something a little bit more formal. So it starts with a security threat model, which is, I guess it's a fairly standard industry spec type document. We're going to have one for every use case in SPDK, every common use case, right? There's so many different use cases for SPDK, it would take forever to write them up. I've got the first one ready to go, and as soon as it gets approved by some internal people, I'm going to post it up on spdk.io. And what it is, the first one is the use case of using the integrated Nvme driver. Okay, and that's a big one for a lot of people, right? We've got so much to offer, but the easiest and fastest way to realize performance results is to integrate the Nvme driver into your application. Okay, so what the threat model does is it gives you a high-level system diagram of what the components that are involved in that use case, where the trust boundaries are, where the attack surfaces are, what the assets that we're trying to protect are, and what the adversaries potentially look like. So all this is jammed into, I don't know, like 5 pages. And the idea is we'll build these out over time. So we'll have one for each use case. And we want to host something similar to our developer meetups. Not really similar, I guess. Has anybody been to one of our developer meetups? All right, so a few of you. We're going to try and do them biannually now. Timing didn't work that good this year, but it's basically a day and a half of community members in a room with no agenda, just getting work done, whatever is the highest priority for whoever wants to speak up. We've had a couple of them. The last one was hosted at NetApp. They've all been very successful. Another thing that we're going to be doing is more like a hackathon. So when we have a sufficient number of these threat model documents done, we will invite developers in the community to come and just sort of assign them a use case and give them the threat model document and say, go to town, try to break this. See if you can find a vulnerability or a security issue. Along with that, we're putting in what we're calling a sub-team, a CVE, Common Vulnerabilities sub-team, which is the core maintainers and a few key members of the community that subteam will be responsible for actually looking at those issues, right? So the last thing we want is a security or vulnerability issue to just be thrown up on GitHub issues. So adversaries can look at it and go, oh my God, look, here's how I attack SPDK, right? Obviously we want them reported, but we want to keep them tightly controlled until we have a solution. Once we have a solution, we will document it, fix it, and tag a release, and then announce it right through the CVE website and also on spdk.io. So all this is just starting, and again, it's very relevant to software quality. We want to expose the vulnerabilities. We want people to find vulnerabilities, and of course, most of all, we want people to fix them. So be looking forward to that on the spdk.io website, probably in the coming month. Any questions on that one? I'm sorry, could you repeat the question? Okay, the question was, will the security model be part of the repository? I don't think we'll check it in with the code. I think we'll put it on spdk.io as documentation. Right, we want to keep the repo for code. All righty, well, if there's nothing else, thanks everybody.